There's a distinction between immediate and retained mode APIs, which started out in computer graphics. So in the immediate API, you would have something like draw circle, which you just call whenever you want to draw a circle. And the retained equivalent of that would be you have a scene, you add the circle to the scene, and then when you want to draw, you call render on the scene object. There's a similar paradigm in user interfaces where the immediate mode API would just have a button function, and whenever the button's clicked, you just handle it on the spot right after the function returns. Whereas in the retained mode, it's the same kind of thing. You have a context object, you create some objects, and you get callbacks when those events fire. We can apply the same kind of thing to animation. So for a YouTube video, you might want to generate a visualization of an algorithm like this. And I'm going to show you how I made this using a simple immediate mode API. So here's what the code looks like. I have this animate function, and I have a wait function and a wait all. So this is the animation for the first part here, where these three pieces of text are animating in. And then for the second part, we're animating the position and scale of the text so that it's out of the way. These other elements are come in. So this animate function takes a pointer to the value that we're going to animate, the target value, and the number of seconds the animation should take. And it's generic, so this is taking pointer to double because we're just animating the alpha of the text. And then down here, these are taking vector 2s because we're animating a position and scale. And because this is all immediate, I can run other code in between animations. So here, once the projection section completed, we're going to set up for the visualization of rasterization, which actually goes through and rasterizes that triangle and writes the data that we're going to use in a subsequent animation. So anytime we want to wait a number of frames, we draw, we run the animations, and we end the frame. And then the other wait constructs are just built on top of that. So waiting for a number of seconds, we just calculate how many frames that is. And when we're waiting for all animations, we just run in a while loop until the animation size is 0. This animate function puts an animation into the list. We maintain a list of animations, which are just functions that we call. And the function knows the start and end index and returns true or false depending on whether the animation is complete. This draw function is called every frame, and it's built on top of an immediate graphics API. So we have things like draw circle, draw line, and it just goes through and draws everything that it wants to draw. I think the main advantage of immediate mode is that you get a procedural style of programming, where each line is essentially one operation, and then you always know where the code is running at any point in time. You just follow it top to bottom. In a retained API, you would essentially have an animation graph, and at that point you're implementing a state machine, which a computer program is already a state machine, so I'd rather just do that in code than in a data structure. I'm working on a longer form video about computer graphics, so as I make more animations with this API, I'll see whether or not I run into any limitations, but I feel like it already does pretty much everything I need. I'd be interested to know what you think, so let me know if you have any ideas for improvements, and I'll do a follow-up video to this one if I add anything substantial. But until then, thanks for watching.